Good morning, good evening, good afternoon, friends. Welcome back to another session. What we are going to cover today, if you see, it's a average and mixture problem session one. So in this class, what we normally do is we take one topic at a time. We learn the basics that we for average and mixture we did in the previous session. I'll link the video in the I button or in the description box. You can revisit that, but it's highly recommended that you revisit that concepts. There are certain concepts we just covered today or the last time in the last video. But those are the typical concepts or applications we should be applying here. So without knowing them completely, if you just seeing this session, you may find it difficult. Find it not difficult, but some missing links in terms of understanding. So I recommend go back, see that video, and then come back and solve this problem together. So here we are going to solve around 6 to 7 problems, which are kind of foundational in nature. And then what we are going to solve typically is slowly we will start raising the bar. In the next session, we are trying to solve more of advanced level problems. And if by that advanced level problem, I mean level 2, level 3 type of problem. But by no means you can think that problem session 1, the problems we are going to solve will not be relevant from our exam point of view. If you see in NMAT, IIFT, few CAT problems also we have included in there. And so there are equal, I won't say equal, but there are decent amount of possibility of problems coming from this session compared to the next session. Obviously, the next session is more closer to the exams type of problem in terms of CAT and ZAT, but this session is more closer to the type of exams like NMAT, IIFT. But having said that, there are certain problems from this session we are going to solve has also appeared in the CAT earlier. But this session again focuses on the foundational understanding through problem solving and what we learned in the previous session in terms of average and mixture. We'll try to revisit those concepts. So with that, let's get started with the first problem of the day. In a minute. Yeah, if you can see the problem, they said in a class, there are two sections, like section A and then section B. There are two sections with an average of 30 marks for 50, A got 50 students with an average of 30 marks. So 50 students, 30 marks. So this is student, this is marks. B contains 75 students with an average of 40 marks. B contains 75 students with an average of 40 marks. What is the average? So basically, this is a typical weighted average problem. But again, I highly recommend if you are seeing this session with me, pause the video as I show the problem, try to solve it by yourself. Take 3 to 4 minutes. Try to see if you can solve the problem, come back and then see the solution. So that's how this session will be most beneficial for you. Don't follow with me in continuation and see the solution right away. Just take a pause the video, do it by yourself, try it out, and then come back after 3 to 4 minutes. If you're not able to, come back and see. So this is a typical weighted average problem. So what are the weights here? Consider, so weighted average, if I know the formula, it's the weighted average is basically W1 X1. So when there are, let's say, two groups, so whose first group's weight is W1 and say average is X1, plus second group's weight is W2, average is X2, divided by the total weight. So what I mean by weight is the number of entities in that particular group. So here the number of students are the entities. So this part is W, the weights, and this part is X, or the individual averages. So if I can use this formula, so then it becomes 50 into 30 plus 75 into 40 divided by 50 plus 30. So 50 into 30 is 1500. 75 into 40 is 3000 divided by 80, or 4500 by 80. Just a minute. Am I doing it right? Just a minute. Okay. So this is not 50 plus 30. This is 50 plus 75. Sorry. This has to be 125. So if I just ignore this part, so this said 4,500 by 125. You do typically, if you divide by 25, so bottom becomes 5, 180, what happens is 36. And this is the way you can do it. And the average is 36. Let's do it in the other way. Here we have told you in the class. So this is one way, directly using weighted average formula. There is also another way to do it by using the weights. If you remember, in the last session we talked about the weights and how to get the ratio. So if you remember, we talk about, if this is the line, the first average is at 30, second average is at 40. So my weighted average will lie somewhere in the middle, not in exact middle, but somewhere between 30 to 40. Then at the end of 30, and this end of 30, at this end, we have the weight of the 50. And at this end, we have the weight as 75. So what's the ratio of the weight? So the ratio of the weight is 2:3. So if the ratio of the weight is 2:3, then the distance of this is, let's say, weighted average. So this distance should be 3x and this distance should be 2x, because weight is in the 2:3 ratio. Your distance of weighted average from each end should be in the reverse ratio. So 3x is to 2x. So if I add this, this becomes 3x plus 2x is equal to the gap between 30 to 40. How much? It's 10. So 5x is equal to 10. So x is equal to 2. That means 3x is equal to 6. So if 6 means, if you add 6 here, this point is nothing but 36. This is another way of doing weighted average. Whatever way you are feel comfortable, you can go ahead and do it. Let's move to the next problem. If there is any doubt in the previous session, you can come back. We'll be able to, you can drop a note in the comment or drop me an email, the mail ID given in the description box. We can take it forward. Yeah. Okay. It says fresh grapes contain. Okay, I'll come back to this problem. This is actually a cat problem. I'll come back to this after a certain time when we solve few more foundational problem. Third, okay, this also is an allegation problem. We'll come back to this in this session. Let's solve few of the easier problems to start with. They said how much water should be added in the 16-liter mixture containing the milk and water in the ratio 3:1. That the new ratio becomes 2:3. So before that, to revisit, so if you mix item 1 with, let's say, item 2, and let's say this is your typically has 7 rupees per kg, and this is typically 5 rupees per kg. So what will be the mixtures? What will be the mixtures price if you mix in certain quantities? So then it's basically how you calculate is higher price. I'm just revisiting the graph. Higher price, average price, and this is low price. So low price here is 5, higher price is 7. So if you do lower price minus average price, you get the quantity of higher price, And if you subtract average price from the higher price, you get the quantity of lower price. So basically, how much of the lower price item should be used and how much of the higher price item should be used, that ratio. So basically, this is the ratio you get. Don't think you get the absolute value. So if your higher price is 7, and let's say the average price, the lower price is 5, typically the problem will be mix item 1 and mix item 2, and then tell me uh, how much should I mix item 1 with mix side and item 2, so that my average price is, let's say, 6 rupees. So then 7 minus 6 is 1. Now 6 minus 5 is also 1. So this is 1:1 ratio. So you have to mix them equally. So, but this is the typical formula for mixture and allegation. Sometimes they will give you the average price and ask you the ratio of higher price quantity versus lower price quantity. Sometimes they will give you the quantity and ask you to find out the average value. Obviously, the higher price and lower price is given to you. So let's see, we will solve most of the problems, at least few of the problems, including this and next few ones using this. And this is the most common way to solve mixture on a problem. Again, quickly recapping what we covered in detail in the last session. So if you need more details, you can go back, see the video of previous session, which is average mixture allegation in basics. And then you will be able to relate to this much better. Let's move on. So I'll just see this problem. I'll just keep the formula. So this is this part. We'll keep this formula for your reference. So they said, how much water should be added to a 16-liter mixture containing milk and water in the ratio of 3:1? So water ratio is 1/4 or 25%. Now, if you are adding a mixture, that means if you are adding water, add water. So the water content must be 100%. And they said in the resultant mixture, the water should be 3/5, such that the new ratio of milk and water is 2:3. So new water should be 3/5, or let's say 60%, right? So I know the water in each of them. So, and take any one. If this is the kind of thing, you can take any one quantity and do the formula that I have shown here. How to do that? Again, what is the higher? There is no price, but percentage is higher. So the start with then higher percentage, that is 100. The lower percentage is 25. Your average is at 60. So they said, so this is the pure water. This is your initial mixture, and this is the target mixture in the result. So basically, they said how much of this should be mixed with this. So again, we'll get the ratio. So 100 minus 60 is 40, and 60 minus 25 is typically give you 35. So 35:40, or 7:8 is the ratio of water. So this is the ratio of water to actual mixture. Oh, sorry, not actual mixture, water to initial mixture. If this is the ratio, 7:8 is the ratio for water to initial mixture. The initial mixture, they have said already 16 liter. So your water should be 14 liter. So 16 liter corresponds to 8x, then 7x corresponds to 14 liter. This is your 14 liter. So you need to use 14 liter of water and mix with 16 liter of water to get the resultant mixture where there is 2:3. Hope it's clear. Let's move on. Okay. Yes. kind of a similar problem to mixture containing milk and water. So if we repeat that in the first mixture, so in mixture 1, your water is how much? 1 by 5 or 20%. In mixture 2, your again water is 1 by 4 or 25%. Resultant mixture contained water of 30%. So result water is 23%. 77 is to 23. That means 23 by 100. So 23%. So again, if I do this, so 25, 23 is the result and 20 is another mixture. So if you do that, so in this mixture containing 25% of water should be in 3 unit, and 25 minus 23 is 2. So 3 is to 2. Okay. So this is mixture 2 and this is mixture 1. So I know ratio of mixture 2 is to mixture 1 should be 3 is to 2. Right? Find the ratio is the 2 mixture will be mixed. Okay. So 2 is to 3 or mixture 1 is to mixture 2 is 2 is to 3. So look what they have said. So they said 2 mixture containing milk and water. In this ratio, find the ratio in which the 2 mixture will be mixed. So again, as they given the 20% water ratio as in mixture 1, so your answer should be 2 is to 3 and not 3 is to 2. Okay, so be a little careful on what you are choosing as an answer. Right? So that's how we can solve it. Let's move to the next one. Again, if there any doubt anywhere you feel it's not very absolutely clear to you, you can drop in the comment section. I'll reply or drop me a mail and I'll be able to respond. Let's go to the next problem. A certain quantity of rice costing 6 rupees per kg mixed with another quantity of rice with 8 rupees per kg, which costed 7.2. So again, I know 6, I know 8, or I know 8, I know 6, so resultant is 7.2. So then this is basically 1.2 and this 8 minus 7.2 becomes 0.8. 1.2 is to 0.8 is basically 12 by 10 is to 8 by 10, or we can say 10 10 get cancelled. So this is 3 is to 2. What is the ratio they will be mixed? So 6 kg rice, 6 kg rice, sorry, not 6 kg rice, the answer is 6 rupees per kg rice is to 8 rupees per kg rice should be mixed into 2 is to 3 quantity, right? 3 is to 2 is for 8 rupees to 6 rupees, right? So it will mix into 2 is to 3 ratio to get it as 7.2. I'll show you some other way if you are interested in that. So let's say 6 rupees per kg rice needs X quantity and 8 rupees per kg rice will be mixed in Y quantity. So X kg of this one and Y kg of this one should give you 7.2 rupees per kg. So basically, then your total cost will become 6x here, total cost becomes 8y here. So using weighted average, we can say 6x plus 8y is the total cost of the mixture, and the total quantity of the mixture is x plus y, and that is equal to 7.2. So this is your total cost of the mixture in terms of x kg of 6 rupees per kg rice and y kg of 8 rupees per kg rice. So this is the total cost, and this is the total quantity. So if you divide, you will get the average, which is given 7.2. If you solve this problem, you will get again x is to y as 2 is to 3. Let's do that quickly for you. So from here, if we can do this, so 6x plus 8y is 7.2x plus 7.2y. So if you do it carefully, it will get 0.8y is 1.2x. Again, the same thing that we started with. So it should be 2 is to 3. Okay. Moving on, they said initially there is a mixture which contains milk and water 3:1. After adding 14-liter water, it becomes 2:3. Again, a similar kind of problem. I'm doing multiple of these problems so that the problem is inscribed in your mind how to solve this type of problem. So again, so if I say initial, and since water is added, let's consider the water's percentage. So initially water is 3:1. Uh, so that means 1/4 or 25%. You have added 14-liter of water, which means 100% of water. So can I say 125, and the resultant water becomes 2:3. So in the result, your water is 3/5 or 60%, right? So 125, so this will be 60. So again, 35 here, 40 here. So but here this is 14-liter water to it, and they have added 14-liter of water. So that means this 35 corresponds to 14. So this 40 corresponds to how much? So 35, let's say 35x is equal to 14. So x is equal to 14 by 35. So 40x is equal to 14, 35 into 40. So 7 to 5 to 8, 16 liter. So it's this kind of similar problem that we did in the previous section. So now you kind of got a hang of how to solve this type of problem, right? Now moving on to a little complex couple of problems that we kept at the start, we kept for the end at the start. Now we will solve them and possibly close the session for today. So then move on to this problem first. So if you, I hope you can see the problem. They said vessel P contains 150 liters. So whenever a arithmetic problem or any problem in fact looks complex in terms of reading, just draw it and just try to do it step by step. Here, let's draw it first. So they said vessel P contains 150 liter of petrol and Q contains 150 liter of kerosene. 30 liters are drawn from P, poured into Q, then 30 liters from Q poured to P. The process from P to Q and Q to P repeated once again at the end. So it looks a little complex. So let's go step by step. So the first step is there is a P, and then next step there is a Q. So vessel P contains 150 liter of petrol and 150 liter of kerosene. So this is petrol 150, and this is kerosene 150. Okay. So 150 liter of petrol, 30 liters of drawn from P and poured into Q. So after step 1 end, so if we see step 1 end, your P has petrol of 120 liter, petrol of 120, nothing else because 30 liter has been drawn. But Q will have petrol of 30 because this 30 liter petrol has been added, and kerosene of 150. So in Q, your petrol is to kerosene now is in the ratio of 30 is to 150 or 1 is to 5, right? Right now. So after the first step end, your petrol is to kerosene is 1 is to 5. Now, if you in the step 2, let's say step 2 end. So now in the step 2, if you add 30 liter back here, so if you add 30 liter back, but this 30 liter will not have only a kerosene, because when we withdraw first 30 liter from here to here, this is 30 liter, this is only petrol. But this 30 liter will not only be petrol, it will be mixture of petrol and kerosene, because you can't draw only kerosene when there is a mixture of petrol and kerosene. But in 30 liter, what will be the contribution of petrol and kerosene? It should be in the same 1 is to 5 ratio. This is the most important part. So whatever be the ratio of two items in the mixture, if you draw a certain quantity of that mixture, in that mixture or in that portion also, like in this case, the 30-liter portion you draw out of 180, your quantity or your percentage of each quantity will remain same as in the original mixture. So 30-liter will also have one portion of petrol and 5% of kerosene. So 1% of petrol. So that means here, what will happen here? So 30-liter means one portion. So 30 should be divided into 5 liter and 25 liter. So 5 liter of petrol, 25 liter of kerosene. So 5 liter of petrol will come to the container P. So then container P pe petrol become 125, and 25 liter of kerosene will again come to container P. So kerosene becomes 25. So the 30 liter you have mixed, you have added from in the 30 liter, 25 liter was of kerosene and 5 liter was petrol. Now here what will happen? Your petrol was 30 liter. Your petrol was 30 liter earlier. You have taken out 5 liter. So your petrol becomes 25. And your kerosene was 150 earlier. Now you have taken out 25 liter of kerosene. So kerosene will have 125. So this is the state of P and Q after the first process. They said this process will be repeated one more time. Let's see if we can do that process one more time. Just minute. So let's see step 3 end. So step 3 end means from here you have put back another 30 liter. Now that 30 liter in the step 3 ka beginning, if you put back 30 liter, this 30 liter now here, now after this case, in this your petrol is to kerosene is typically 25 is to 125, again in the ratio of 1:5. So the 30 liter you pick now, it will have 5 liter of kerosene and 25 liter of petrol, right? So at the end of step 3, you will give away 25 liter of petrol. So your petrol becomes 100, and you will give away 5 liter of kerosene. So your kerosene becomes 20, because it was 25 earlier in pot P. In pot Q, your kerosene becomes 130 because it was 125 earlier, and you are giving back 5 liter from the 30 liter mixture, and your petrol become 50. Your petrol become 50 because it was 25 earlier and you are adding back 20, right? So here now petrol is to kerosene is 50 is to 130, or we can say 5:13 ratio, right? 5:13 ratio. 50 liter of petrol, 1 liter of kerosene. Now again, what we'll do at the last step in the step 4 end. So what is the question? Question is, what is the ratio of petrol and kerosene in P? Okay, so you have to add back another 30 liter, right? So in this 30 liter, your petrol is to kerosene should be in the ratio of 5:13, right? So your petrol, if I just do it here, so basically in this 30 liter, if I just take this 30 liter, in this 30 liter, your petrol will be 5/18 into 30, and kerosene will be 13/18. Let's do something else. Yeah, so if I do it here, the end of step 4, so your petrol, if I take this 30 liter, your petrol will be 5/18 because the ratio is 5:13. So 5/18 into 30 liter, which comes around 3, 5, so 25 by 3 or 8.33 liter. 8.33 liter. So your kerosene will be 30 minus 8.33, or let's say 30 minus 8.33, you do the 21.66 liter. So 21.66 liter of kerosene, and petrol will be 8.33. So in P, in this, kerosene was 20 earlier, so 20 plus 21.66 or 41.66. This is at the end of step 4. And petrol, it was 100 earlier, 100 plus 8.33, so 108.33. So the ratio of petrol and kerosene will be 108.33 is to 41.66. This is the ratio. Obviously, it can be simplified further, but given on the options, you can try it. But this is the ratio that we will be able to look for. So 108.33 is to 41.66. Right. So again, the idea is not try to solve this completely, obviously, with the answer, but the idea, so do step by step, see in each step how much petrol and kerosene is being withdrawn. If you add to the next container, what is the new ratio, new quantity that gets formed for each of them, petrol and kerosene. Then try to see what is the ratio of the new forming quantity as per the new forming quantity. Then again, if you take 30 liter from that mixture, take out in that the new ratio that you have just calculated, and then do that step. So again, do step by step. So, but the main crux here is only one concept we have leveraged is whatever be the ratio of two item in the mixture. If you take a portion of that mixture, in that portion also the ratio will be same as the original actual mixture, and that's what we have leveraged. So your petrol is to kerosene is to 108.33 is to 41.66. You can possibly do it further. So 108.33 is nothing but 108 whole 1/3 is to 41 whole 2/3, and then from there you can go ahead based on the options. Not going there. Let's move to the previous problem, the last one for the day. This is a CAT problem. It came to CAT 2-3 times. So they said fresh grapes contain 80% water by weight and dry grapes contain 20% water by weight. So can I say my fresh grapes is nothing but dry grapes plus water, right? So if I have dry grapes and add water, I will get fresh grapes. So dry grapes pay water is 20%. In water, obviously water is 100%. And in the fresh grape water is 80%. So this is the percentages of water. Okay. So what should be, so this is how many fresh grapes will be required to prepare 20 kgs of dry grapes, right? So if I say dry grape and water, so 20% and 100. So dry grape and water 20 and 100. If I mix them in a certain way, they will give me a fresh grape where the water is 80. So 80 is the target, or it is the average in the mixture, the average weight of the water. So then this should be in the ratio of 100 minus 80, 20, 20 minus 80, 60. So this should be in the ratio of 1:3. So this is dry grapes and this is water, right? Dry grapes and water. So yeah, so you need dry grapes is to water should be in the ratio of 1:3. So you need 20. So basically, can I say x kg of dry grapes plus 3x kg of water should give me 4x kg of fresh grapes. So dry grapes is to water mixing 1:3 ratio gives you the fresh grapes. So if you mix x kg of dry grapes with 3x kg of water, you get 4x kg of fresh grapes, right? So then from 4x fresh grape, I can get x of dry grapes. So to get 20 dry grapes, I need to have 80 fresh grapes. So 80 kg is your answer. So this is one of the very important problem that applies that applies your mixture alligation concepts to the code. So this is about it. So what we have done is we have solved 6 to 7 problems. If any problem anywhere you feel that you need a re-explanation or certain part of the explanation is not clear to you, just drop me a note, like I said, in the comment section or the mail ID given, and we can have a session. And or if can be solved over the mail, I will be able to explain over the mail. So I hope the foundation session is useful. We have solved problems not so simple, but starting from simple ones so that your understanding is get cemented. So in the next session, we will do a deep dive on average mixed allegation level 2 or advanced level problems. And then obviously you need to understand this session and the basic session are very well so that you can relate to the problems that we are going to solve in the next session. So hope this session was useful. Thank you for time and see you next time.